Will perpetual spring ever end? I am Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, July 6th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
If you enjoy the video, give us a thumbs up. If you haven't subscribed, please subscribe. Click the Stormsurf icon down in the lower right-hand corner of the screen. If you'd like to leave a comment or question, please do so. We'd be happy to respond. And if you'd like to make a small contribution to the cause, you may. Hit the super thanks button down below, the heart with the $sign in it. With that, I'd like to thank the folks that donated last week. Tim Caston, Coach Nate, Clay Goose, B. Nadine, and Evolution Moto. These are all our longtime contributors. Thank you all so much. I really appreciate it. With that, let's get to work. We'll start by looking at significant wave heights around the planet. Starting in the North Pacific, not a whole lot going on. A bit of a tropical storm of some sort off of Japan, but not particularly strong. No surf expected from that. We go to the South Pacific, a series of fetch areas. I won't even call them gales, with seas in the 21, 22-foot range, are circulating down around this area. Notice the ice anomaly has significantly reduced its coverage. That is a good thing, especially considering that the ice line is creeping further and further north. In the North Atlantic, pretty quiet pattern is in play. South Atlantic, again, pretty quiet. The main focus, as it has been for a couple of weeks now, the Indian Ocean, with a gale with 37-foot seas here, right here, on all the wave models, at least the ones that are hemispheric. This is the highest seas over the entire image, or the domain, if you want to call it that, and the coordinates. So one with 37-foot seas, another gale here with about 33 or maybe 34-foot seas, definitely generating swell for the Indian Ocean. But before we get into all that, let's take a look at current conditions. We're going to use the buoys. We're going to start up in the Pacific Northwest off of the Columbia River, right there on the Oregon-Washington border. Grays Harbor buoy number 036. We're looking at all the energy that's hitting this buoy, all the way up from 33.3 second period, really long period energetic swell energy, which there's 0.0 feet of, the whole way down to 5 second period, just pure wind chop. Not a whole lot going on there either. And then there is some degree of what one would assume is southern hemi swell hitting. You know, it's not just any one of these frequencies that makes up a swell. It's sort of all this area combined. But on average, 0.7 of a foot in the 15, 14 second period range. Then some wind swell in the 9 second period range. The algorithm puts that all together for us. Primary swell 1.2 feet at 15.4 seconds from 216 degrees, making surf a whopping 1.8 feet. That would be at like a standard beach break, you know, no swell enhancing bathymetry, no reef to amplify the swell. And then secondary swell, the largest of the secondary swell energy, 1.9 feet at 8.8 seconds from 284 degrees, making surf 1.6 feet. Then we head down to Northern California, the Point Reyes buoy, number 029, there just north of San Francisco Ocean Beach. Now we have a bit more pronounced southern hemi swell signature with energy at 22 seconds, another little bit at 18, then some more in the 14, 15 second period range, and then a bunch of wind swell in about the 8 or 9 second period range. Put that all together, primary swell 3.9 feet. Oh, the wind swell wins out. 3.9 feet at 7.9 seconds from 308 degrees. Making surf at 3.1 feet. Oh, yeah, I see what's going on here. And secondary swell, 2.1 feet at 14 seconds from 187 degrees, making this the secondary swell by 1/10 of a foot, 3-foot surf. Then we head down to Southern California, the Point Loma South buoy off of San Diego, buoy number 191. The southern hemi swell pattern, much more pronounced. Wind swell completely attenuated by the Channel Islands. Now look at this, new energy building in. This is the previous swell fading out. So new energy, peak band 1.1 feet at 18.2 seconds. Previous swell fading from 1.3 in about the 13 to 14 second period range. Let's see what the algorithm says. Primary swell 2.1 feet at 13.5 seconds from 194 degrees, making surf at 2.8 foot. But then here is the new swell, the secondary swell, 1.6 feet at 17.4 seconds from 191 degrees, making surf, oh, look at that, 2.8 feet as well. There must be some rounding in there, and that's the only difference. So two swells, almost the same size for the moment, but the secondary swell likely is going to take over within a couple of hours. Then we head over to Lanai to get a beat on what's going on the south shore of the Hawaiian Islands. You see a broad spectrum of energy here, anywhere from 20 seconds down to 5 seconds, all almost equally represented. I'm sure the algorithm will have a fit over this. Primary swell, 1.2 feet at 15.9 seconds from 190 degrees, making surf at 1.8 feet. Secondary swell, 1.3 feet at 12.8 seconds from 187 degrees, making surf at about 1.5 feet. I mean, I just looked, it's probably waist high, maybe chest high on the biggest sets at the top spot. So algorithm seems to be doing more or less okay. Right, so what's been going on for the past week? We're going to start in the northern hemisphere, North Pacific specifically. Just California here, Hawaii down here, Alaska, Aleutian Islands. Just run through this. See, there's your wind swell signature. This is part of the title again of this video, is the perpetual northwest wind swell generated by high pressure. I mean, honestly, it's probably not that unusual, though it seems like it is. Now we're going back in time here. Here's Wednesday, July 2nd. Tropical system formed south of Cabo San Lucas. Pretty much died out within about 36 hours. No significant surf for U.S. breaks occurred. Another system developed off Japan. It lifted north. Whoops, there we go. And there we are currently. It's still off Japan. Likely not going to do anything. Northern Hemi this time of year, no one would expect anything from it. Now the Southern Hemi, a little bit different story. We have one swell that's been hitting California for the 4th of July weekend. It is starting to fade. Another gale developed here in the Southeast Pacific on Saturday, the 28th of June, lifting north with 29.2 foot seas right there. And then back to like 23 or 25 foot seas. Faded out rather quickly. That is the swell that is starting to hit now. You see the gale was rather short-lived, and likely that swell will follow the same profile. Looking beyond that, we're into Wednesday. Gale developed, falling southeast, no energy pushing off to the north. We're into Friday. We're looking for anything. Now, a little tiny gale did develop Friday night, the 4th of July, here with 31-foot seas, lifting north with 32-foot seas. It almost looks like 33 feet. And in the both North and Southern California swell window, see, that was it. 2 readings above 30 feet. That was for 12 hours. 18Z Saturday, it's already fading. And by Saturday night, it was east of the Southern California swell window, San Diego at like 118, 117 west. And that was the end of that. Oops. And there we are. Oh, this is interesting. Here, we'll go forward. This is going back to the 20th. There's the ice anomaly. Now, here's where it is now. Also, look at this, going back 2 weeks. Now, you can see the ice line here, and then let's move forward a little bit. You see it still creeping to the north. So, we are not at the peak of winter in the Southern Hemi yet in terms of ice production. The more the ice grows to the north, the less room there is here in the Southern Hemi for storms to form, because you can't get surf. Well, you can get the storms, you can't get the surf because the wind can't blow if they, and impart energy to the ocean if it's covered in ice. To the North Atlantic, another little gale there with maybe 16, 17 foot seas on Monday, the 30th of June. Impacting North UK, Ireland region. Another little fetch area impact the same area on Friday into Saturday, and here we are current time and nothing else. Oh yes, the remnant fetch. Let's go back and examine this. Was it Chantel? Let's see if we can pick up. We actually picked up a peak sea reading of 12.6 feet, targeting, I would say, mainly North Carolina, maybe up into the Outer Banks. But as of now, that is fading fast. Looking back the past week for the South Atlantic. There we go, little system, 22-foot seas on Sunday. That disappeared on Monday. Pretty quiet pattern then ensued until we got into about Thursday and Friday. Notice 28-foot seas on, this is really Thursday night, targeting South Africa, building to 30 feet, 31 feet. Additional fetch there, but it started falling southeast. But because it's so close to the coast here, what are we talking about? Every 10 degrees is about 600 nautical miles, so relatively close to the coast. More swell definitely is radiating north. This was on Sunday. Seas were building to 37 feet, 39 feet. Now look at this, though. They're all aimed south or southeast at Antarctica. There is a little fetch back here aimed at South Africa, so yet more swell is likely being generated as this moves into the Indian Ocean proper. And then on Sunday, in the Indian Ocean itself, we're going back a week, Sunday a week ago, 26, 28-foot seas and the other area of disturbed weather. You can see, oh, there we go, 29-foot seas. Really, like 28 feet is what I look at as the minimum for producing a decent-sized swell or decent period swell. You get 16 seconds out of that. And there we go. Something aimed north towards the Mentawai Islands and Indonesia. That one faded out on Wednesday into Thursday. See if here comes another one. This was as of Saturday, so just 24 hours ago. 30-foot seas, building to, I'm guessing that at 36 feet, because this guy you only get one peak sea reading. You don't get a secondary one. So like 36 feet aimed north towards Western Australia and Indonesia as well. Pretty good, healthy, robust pattern for the Indian Ocean. So let's go do a deep dive into the Pacific Ocean, specifically the South Pacific Ocean. Let's take a look and see what's coming for the next week. We're starting by looking at Jetstream level winds. These winds up about 30,000 feet help support the formation of gales. When those gales form, help direct their track. We're looking for a trough, a push in the jet to the north, just like what we have right here. Now keep in mind the ice line is somewhere around 63, so we got to kind of get north of that line. But anyway, if you get a trough, this pushing the jet to the north, that helps create a clockwise flow aloft and down at the ocean surface. That's the hallmark of low pressure. And of course, low pressure, if it's strong enough, generates winds. Those winds get traction on the ocean surface, generating seas. Those seas, as they radiate away from the fetch area, the lesser period elements of the sea state fade off or dissipate or decay, exposing longer period swell energy. And of course, swell, when it hits your beach, creates surf. So we have a trough. It's a good start on Sunday. Pushing to the north, continuing to build more energy, forecast to build into it on Monday with 150 knot winds. Let's see if we get any higher than that. Nope, about 150 knot, but that is a well-defined trough right there. That continues into Tuesday, still in the Southern California swell window, San Diego at about 117 west. Wednesday still, but notice wind energy starts fading. Also notice behind that, the jet starts really falling south. That is a ridge. That is a ridge, and that ridge, of course, when you get this like big split pattern, that supports high pressure. Let's see, that would be a counterclockwise flow aloft, and that does nothing to support storm and long period swell production. So as of about Wednesday, the 9th of July, the trough, for the most part, is either too weak or pushing east of the Southern California swell window. All the focus is somewhere here in the very deep southeast Pacific. We're out 120 hours. We're into Friday and Saturday. Look at how big this ridge is pushing south under New Zealand. No swell production there, but look at this. Looks like another trough potentially on Sunday, with good winds lifting hard north and just barely north of the ice line. Questionable about whether it would be in even the Southern California swell window. We'll have to keep our eyes on that, but there is some hope. Next up, let's go take a look. Surface level pressure, surface level winds. Current time, 12Z, Sunday, July 6th. We have a bit of a gale developing southeast in New Zealand. Bear in mind the ice line right here. So half the gale's probably over ice. The other half is not. We really need at least 40 knot winds. There we go. A little tiny area, 40 knot winds to generate meaningful seas. Also notice the gale with 45 knot winds targeting South America, but well east of the Southern California swell window. This other gale here, so we got 1, 2, 3 gales. This one totally over ice. Put this into motion as we get into Monday. Now we have a decent size area, 40 to 45 knot winds aimed well off to the northeast in both the Hawaii and the California swell window. That holds as we get through the day into Monday. And then we have like this multiple 1, 2, maybe even 3 or 4 different fetch areas, low pressure, trying to get itself organized, but it sort of is all pulled apart, not doing a whole lot. I mean, lots of energy pushing towards South America. That'd be Chile and Peru, but not so much really towards California. Here we go. It theoretically builds again on Wednesday, 35 knot, 40 knot. No, there's your 55 knot winds, but that's all aimed south. So we'll just put this into motion. Now there is a legitimate storm with 55, 60, maybe even 65 knot winds in the Chile swell window, but sort of falling southeast, still just based on how close it is. Some swell should result there, but probably nothing for California from that. We put it out, then move it out. As you see, strong high pressure, 1036 millibar high taking over, completely bearing the southwest and south central Pacific. We're into Friday, Saturday, no real change. We know there is another trough. There we go, 35 to 40 knot winds, lifting well to the north on Sunday. Actually looking halfway decent, but the ice line somewhere here, probably the bulk of it is over ice. We'll just have to see how this plays out. All right, so what effects are those winds going to have on the ocean surface? We're here looking at the significant wave height model again, 60, maybe 64 south is the ice line for the moment. We have a gale developing here. This is the one we're really keeping our eyes on. As we get into Sunday night, up to 30-foot seas, building, lifting off to the north, 31-foot seas, building to 33 feet, holding at about 32 feet, lifting pretty well to the northeast. So some swell should result from that. About a week out to get up into California and something less for Mexico down into Central America and Peru. Also fetch here. This is, for the most part, east of the Southern California swell window, but targeting South America. That system all kind of fades out. Then we have this complex gale pattern starting to set up here off of Patagonia. You see seas to 50 feet. Can we get even a higher reading? I thought I saw one. Yeah, there we go. 51 feet. But again, that is probably even, for most of it, east of even the Chile swell window. And there you go. It finally blows up with 56-foot seas to 58 feet. We're at 100 hours out. I'm looking here because there's nothing else going on back to the west. We'll just put this into motion. We're 132 hours out, looking for anything, but we know big high pressure is over here. Here we go. Oops, and there we go. You see the last little system here trying to get organized. It's 180 hours out. Not really believable, and that's probably not anything that I would bet money on. All right, so now we'll try to play the same game in the North Pacific. We have a tropical system off of Japan. Lifting north, it fades out. You still see this kind of weak low, it's likely weak low pressure generating seas at what, maybe 10 feet. I mean, you're not going to get anything from that. But it speaks to the consistent low pressure pattern. Here's the local gradient. We'll get into that in a minute, but it starts generating seas along the California coast. We're into Friday, Saturday. Another tropical system, almost a week out. Would never believe the GFS model about that. We're a week out. So North Pacific, not unexpectedly asleep. Going to the North Atlantic, we'll put this into motion again. Wouldn't expect a whole lot here. little bit at a time as we transition deeper into, I guess it's officially summer, but really it still sort of feels like spring. You see fetch, low pressure in the North Atlantic, but not really getting much traction anymore and becoming pretty ineffective at producing surf. To the South Atlantic, we'll put this into motion, looking for any new fetch. Here's 23-foot seas targeting South Africa, building to 25 feet there, and then up to 26, if not, there we go, 28-foot seas. This is on Wednesday, the 9th of July. Certainly swell for Jeffreys Bay in South Africa from this. And then more fetch right after that. Looks like a good long run of perhaps locally generated swell, but one, starting about midweek, and that continues on into the weekend. But then by Saturday, things start mellowing out a week from current time. And then finally, the Indian Ocean. All right, we know we have a system under Africa falling southeast, doing nothing. Another system off of southwestern Australia with it looks like about 34-foot seas, but falling southeast. Swell likely to result from that if it's not already impacting the coast. Another system with 28-foot seas pushing right up into South Africa. South Australia. We're into Wednesday, in Thursday, the 10th of July. Notice a big system. Sideband energy likely. Seas 44 feet. Yeah, probably will be some long period energy. Now it actually doesn't start dropping any further south, just tracking east. So yeah, some swell likely from this as well long term. We're into Friday the 11th. And yet another system down here with 42-foot seas, holding right at 42 feet. We're into a week from now, the 13th of July. A very active pattern seems focused somewhere between, we'll say, Africa, the whole way across the Indian Ocean, but not making it into the Pacific Ocean. Local wind forecast for California and Hawaii. So Southern California down here, Central California, San Francisco Bay right there, Northern California. Hawaii here, high pressure in control, generating northwest winds, 20 knots, again, pushing down the California coast, pretty typical of a spring pattern, generating wind swell. And then we now have easterly fetch pushing into the Hawaiian Islands, generating small easterly wind swell there. Move into Monday. Gradient becomes a little bit more defined with 25 to 30 knot north winds, but you see this sort of likely an eddy flow or at least a light northwest flow for anywhere south of, let's say, Point Arena. Trades continue 15 knots for the Hawaiian Islands. As we get into Tuesday, the gradient completely fades out. High pressure backs off. A light wind regime. Hooray! Finally a break. Trades 15 plus knots for the Hawaiian Islands. Wednesday, you see high pressure here trying to again start nosing into California, but not getting too much traction, not doing anything for wind swell production. Trades, though, already building over the Hawaiian Islands at 15 knots. Thursday, here comes the gradient. Northwest winds 25 knots, the whole way from Point Conception northward. East trades 15 knots. Get into Friday, and here we go. Full-time, springtime pressure gradient again. 30 knot winds solid from, we'll say, Point Reyes on northward. Trades 15 knots, solid for the Hawaiian Islands. Saturday, the gradient gives up a little bit of room, so lighter winds for Central California. Holding through the day. Gradient actually not that strong. Probably the low pressure up here helping to take a little punch out of the high pressure, though trade still 15 knots for the Hawaiian Islands. And then we're into Sunday. The low fades, the gradient starts building yet again. So same sort of pattern. The hiker's temperature forecast for the intersection of the Pacific Crest Trail and Tioga Pass Road there in Yosemite. The elevation at that intersection about 8,700 feet. Sea temperatures in the, so let's see, this goes the whole way down from, this would be sea level up to 14,000 feet. But at that intersection, temperatures generally about 50 to 55 degrees, 60 degrees more likely. And if you're in the sun, it's a lot warmer than that. Till you get into about Thursday, the 10th of July, then temperatures start working up into the I'll say 65-degree range pretty much. And then 70, if not 75 degrees as we get into Tuesday and Wednesday. And notice this, we have temperatures in the 100+ degree range down at lower elevations early a week from now. Again, now that is a model going out a week, or this actually goes out 10 days, but you get the idea. Model's hitting at warm temperatures, if not hot temperatures, over probably the Central Valley a week from now. And just a quick look at snow coverage and general weather. This was from 3 days ago, up at about 9,300 feet. This is up in Desolation Wilderness near Dick's Pass. We'll just put this into motion. You can see there is still a fair amount of snow over the higher elevations. Not impassable, but there are definitely lots of significant snow patches and snow fields as we we're up at, approaching the 9,000 foot range and above. You can see, and then there's Dick's Peak. That's up at like 9,500 feet. So you get the general idea. All right, so what's all this mean in terms of surf? We're going to start up in the Pacific Northwest. Again, Columbia River there, intersect the border between Oregon and Washington. Heading south to Ocean Beach, San Francisco. Surf heights, just wind swell, basically, 3.5 feet. Though we know there is some real southern hemi swell building underneath this, but it isn't enough to make it be above the wind swell height. Notice winds picking up as we get into Thursday, Friday, then larger wind swell by the weekend, out a week from now, 6 feet, something like that. Swell heights, 3 feet at 9 seconds. Here's the tail end of the southern hemiswell, but we got all masked, so you can't really see it here. And then more wind swell, 6 to 7 feet at 9 seconds by the time we get into next weekend. We can see the southern hemiswell, though, down in the San Diego area. Or Dana Point. Let's do it that way. All right, surf heights 2.5 feet Monday, 3 feet on Monday into Tuesday. Then it looks like the wind swell takes over here. And so it gets kind of convoluted. Let's see if we can tease out the swell. Here we go. So fading swell, 2 feet at 13 seconds. We get into Monday. Building swell, 2.3 feet at 14 to 15 seconds. Getting into about Tuesday, then that fades out. The wind swell takes over. Then we have another southern hemiswell by next weekend, 1.2 feet at 16 seconds, 15, 16 seconds, something like that. So more southern hemiswell on the way, but not huge. We go to Oahu, surf heights in the generally 1.5 to 2 foot range the entire week-long period. Trades 20 knots, pretty much non-stop. Surf heights 2 feet at 8 seconds. You see bits of background southern hemiswell, 1.2 at 17 seconds, 1.5 at 16 seconds. So there will be rideable surf on occasions, 1.7 at 13 through the week, and then plenty of easterly wind swell. On to Jeffreys Bay, where they're just getting hammered, swell after swell after swell. When you see the heights drop off like this and you see the winds up like this, it's all wind swell. It's not even pure swell. But at some point, surf heights in the 18, 16 foot range on Monday, trickling down, then coming back up to 24 feet on Thursday. That would be off the coast, something less at Jeffreys Bay. Then really theoretically building big 38 feet as we get into the early part of next weekend, Friday into Saturday, fading down from there. Swell heights, 15 feet at 12 seconds, 10 feet at 14 seconds, and then another 17 feet at 14 seconds, and another 26 feet at 14 seconds. It is winter in the southern hemi, and Jeffreys Bay is right on the opening door to where all the storm activity is. Then finally to Bali, further away than Jeffreys Bay from the fetch areas for sure, but everything that comes in a lot more groomed. Surf heights 5 feet for Monday, Tuesday, going up to about the 11 to 12 foot range on Wednesday into Thursday, trickling down and then maybe coming up again on Sunday a week from now in the 9 foot range. Swell heights 7 feet at 15 seconds, 7.5 at 15 seconds, trickling down from there, and then up to about 5.5 feet at 16 or 17 seconds next weekend. Very nice pattern indeed. All right, let's go take a look at long term and see what's going on with our two major weather oscillations that affect storm and swell production. That is the MJO, the Madden-Julian Oscillation, and ENSO, the El Nino Southern Oscillation. We'll start with the MJO, the Madden-Julian Oscillation. It is this periodic weather oscillation, depending on where you live, that has two phases, the active phase and the inactive phase. Both the active phase and the inactive phase are polar opposite each other around the planet. They rotate around the equator west to east. When the active phase of the MJO moves into the West Pacific, it is effectively like a low-pressure system. So it takes warm, moist air at the ocean's surface, lifts it aloft. That warm, moist air eventually gets up into the jet stream level, energizes the jet stream, making it stronger, and therefore a stronger jet stream more capable of digging out troughs and producing storms. The inactive phase is the exact opposite. It's like a high-pressure system. It creates falling air. That falling air cuts off supply of energy to the jet stream, and you end up with a big split, typically, jet stream not capable of supporting gale formation, like what we're seeing in the West Pacific, in the Southwest Pacific, like over the next week or so. All right, but the active phase of the MJO, because it's a low-pressure system, it helps reduce trade winds. Trades are generated by high pressure. So what the active phase of the MJO does is reduce trades, and we can see that or it does show up in some of the charts. They call it westerly anomalies. The net effect is almost like a west wind. The inactive phase of the MJO, it being a high-pressure system, it interacts positively, constructively interferes with the base high-pressure state in the Pacific, and therefore increases trade winds. All right, so we're looking at data from the TAO buoy arrays. Here's the buoys strung across the equator used for monitoring El Nino, but there are wind sensors on the buoys. The arrows depict those winds, direction, speed. It's a 5-day average wind, so it's not like by the hour or anything like what we're used to. But because the active phase, the MJO, can dampen trade winds, that's what we're looking for. And the active phase, because it's low pressure, also helps feed storm development. All right, so we're in the far East Pacific. The arrows pretty strong out of the east-southeast, so pretty strong trades there, pretty strong trades over the Central Pacific, and pretty strong trades over the West Pacific. Oh yeah, this is the West Pacific, East Pacific there. There's the equator. 180, that's the date line, that's New Guinea there. So you see pretty healthy trade wind pattern across the entire Pacific. But it is not the actual speeds themselves that matter. It is the difference from normal for this time of the year. So there's an average, they have calculated average wind speeds for every square degree of the Earth for every day of the year. Going back 30 years, you get an average for July 7th for the past 30 years, compared today's winds to that, and then you know whether the trades are weaker or stronger than normal. In the East Pacific, you see a couple little baby arrows out of the east here. Now, it's only 5 degrees north and south of the equator that really matters. So I'd say trades are almost normal, just weakly stronger than normal. In the Central Pacific, pretty much dead normal. Now we have the east arrows here, suggesting trades a little bit stronger in the West Pacific. So I'd say probably some flavor of a weak inactive phase here, and some flavor of a weak inactive phase over the entire Pacific. So no real help there. Maybe even no MJO at all. Let's keep digging. Here's the trade wind pattern, what it has been and what it is going to be, theoretically, per the GFS model, for the entire planet, right? 180 is the date line. Far West Pacific starts about 135 east, so roughly right about there, okay? And it is the West Pacific where the trade winds have the most influence, because the jet stream runs across this pattern from west to east. So the west winds, they're lifting Oh, and yellows and orange are west winds. So if the jet stream's coming across here, it hits this area, picks up energy from the rising moist air, makes it stronger as the jet stream traverses the Pacific, and therefore makes it better for supporting storm production. If the west anomalies are somewhere over in the East Pacific, it really doesn't do a whole lot. It does good for supporting tropical storm development, but not for generalized swell production, what we're looking for. All right. So anyway, here's the pattern. The blues, easterly anomalies, the reds and yellows, westerly anomalies. Again, the far west Pacific right about there. So you see we've been dominated by this easterly wind pattern. But notice, starting somewhere here in late June, the westerly anomalies started making inroads into the West Pacific. And just looking down here, well, this is halfway across what I call the Kelvin wave generation area. It goes the whole way to 170 west, but you get this sense that the forecast, or at least now right there, just 1 day's worth of, and this is a day ago. So by today, the 7th, theoretically, we should have normal to light westerly anomalies in the West Pacific. And that is forecast, if anything, growing slightly in coverage to almost 175 east 2 weeks from now. So these are about 5-day increments, something like that. So you can see a building, I don't know if I'd call it an active phase pattern, but this perpetual easterly anomalies, that's still the La Nina signal in the atmosphere. I mean, by all accounts, La Nina is dead, but the atmosphere, the wind pattern, still looks like it's present. La Nina can die, but its effects linger in the atmosphere for at least 3 months after it dies. And we still see that clear easterly anomaly signature in the atmosphere, though the sense that westerly anomalies are steadily building. It's not even a forecast anymore. They are steadily building in coverage over the West Pacific. That gives us hope long term. The outgoing long wave radiation forecast for the next 2 weeks. Yes, I am not showing you a blank chart. This chart, if there were data, if there were blues, that would suggest rising air, warm moist air rises, condenses as it hits the upper atmosphere, cold air, creates more clouds than normal. That would be the active signal. The reds and yellows, the opposite, falling air, clear skies. This suggests neither red nor blue. This is a statistic model just saying as neutral and a MJO pattern as one could possibly want. And then looking at the GEFS model, neutral, but then notice here comes the blue signal, cloudier than normal skies, active signal possibly building in the West Pacific 2 weeks out. Let's go see if we can see something more detailed. Here's phase diagrams for the same two models, statistic model here, dynamic model. This is where the active phase, the MJO, has been. Oh, how do you read the chart? The MJO moves from west to east, from the Indian Ocean, to the maritime continent, over the West Pacific, East Pacific, under the United States, across the Atlantic, over to Africa, back to the Indian Ocean. The heavy dot, which is like somewhere like there, shows you where the active phase is, I'll say over the maritime continent. The further away the dot is from this circle, like out in here, the stronger it is. This dot is as far to the center of the circle as you can get, so basically a non-existent MJO per the statistic model. Now the dynamic model has the MJO noodling around here and at least being weak over the maritime continent, moving to the West Pacific 2 weeks from now, but by and large, still a relatively weak MJO signal, just like what we were seeing last week. Now here's the CFS model, a dynamic model going out a month. Again, date line right up the middle of the chart. West Pacific starts about 135, maybe 140 east, so somewhere over here. Now this shows the MJO, the black contour, solid contour, active phase of the MJO. According to the CFS model, at least this depiction of it, we are in the active phase of the MJO, and it is to continue pushing across the Pacific in the Kelvin wave generation area till about, I'd say about the 19th or 20th of July. So we got another week and a half, 2 weeks with westerly anomalies. building for the whole way across the date line into almost a point south of California. Now remember, this is just 5 degrees north and south of the equator. Yeah, right there, 5 south to 5 north. So active phase in control for the next 2 weeks, then some sort of a easterly wind pattern, at least according to this after that. So probably an inactive phase. And then we have the CFS model going out 3 months, right? Past performance is down here. The forecast is up here. The blues, easterly anomalies, inactive phase, or the La Nina signal. The yellows, active phase, or the El Nino signal. All right. You can see, oh, and the date line runs right up the middle. West Pacific starts about 135 east, so somewhere about right there. So you see, here is our La Nina signal, just eyeballing this. Strong easterly anomalies. Somewhere in April, they started breaking up, and then you start seeing little bit and a little bit more of the yellows, westerly anomalies setting up. And then here we are, the 6th of July. Oh, this is a day behind as well. The 7th, by about the 9th, westerly anomalies taking over. And as we get further into this, you see westerly anomalies filling almost, I would say, from about 175 east. That'd be pretty much the entire western third of the West Pacific as we get into the fall. Now, easterly anomalies still over the East Pacific. Let's overlay the MJO here. Let's take a look, see what we get. Okay, so here is our very weak MJO pattern. And yeah, here's our active phase that we're in, exceedingly weak. And as we get about a week out, according to this model, or a week and a half, it's supposed to fade, though westerly anomalies continue. Weak inactive phase follows behind that from 22nd of July into about the 7th of August. And then after that, and the models have been rock solid about this 1, 2, 3, 4 contour, active phase of the MJO setting up to kick off the beginning of fall on August 31st. I don't know whether I believe it. I'll be honest with you. I mean, that's out another month and a half, almost 2 months. But the models have been consistently showing this, so I guess we'll just have to see. Either way, it suggests that the La Nina signal, well, in fact, let's just overlay the low-pass filter. We'll see it for ourselves here. Okay, this is the La Nina El Nino indicator. The black solid contour is a low-pressure bias. That is the La Nina signal. I mean, the El Nino signal, I'm sorry. It is over the maritime continent right now and has been. But notice, little bit at a time, it's supposed to be easing west, making it to about 160 or 165 east at the end of the model run, October 2nd, with a second contour developing. Perfect timing as we move into fall. With the La Nina signal with 1, 2, 3 contours, then 2, and now just 1, and literally a week from now. This is the big part. The high pressure bias here, this is the La Nina signal, supposed to completely carve out here for almost a month in August, returning some, but once it returns, the low pressure bias is also building and strengthening and has made a foray into the West Pacific. So this sort of suggests that, well, maybe some change is afoot and hopefully in the right direction. Let's keep digging. What is going on down in the ocean? Not at the surface, but down deep in the ocean. We use the depth and the position of warm water in the South Pacific, or in the Equatorial Pacific, to get a sense of what is happening. The trade winds affect all this. The stronger the trades, the more warm water balls up in the west. The weaker the trades, the warm water starts pushing to the east, and in El Nino develops over in the East Pacific. All right, so we're looking at the, these are anchor lines for the TAO buoys. The X's are sensors on those anchor lines. The sensors with that data and a model to sort of fill in the gaps in between gives you a sense of the profile of the warm and cold water in the Equatorial Pacific. The 29-degree isotherm, it had moved back some to almost 180 last week, but now it's starting to move off to the east a little, about 177 west as of right now. The 28-degree isotherm pretty much holding. It's been fluctuating somewhere between 58 and 160 for the past week, so no real change there. One thing I did notice, though, is the 24-degree isotherm, which was down at 25 meters last week, is all of a sudden very shallow right along the coast of Ecuador. So a little bit of maybe resurgence of trades in this area, but it is not the actual water temperatures that matter. It is the anomalies, difference from normal from this time of year. According to this, we're in great shape. The entire isotherm, it normally starts about 150 meters deep. The whole way across the Pacific is full of warmer than normal water, just 1 degree here, up to 2 degrees over here, and actually getting deeper in the West Pacific, or in the East Pacific now. So, and there was some signs of coolish waters off in here, but that really has faded off. So looking pretty healthy from this chart. Let's go look at another one. Here's the same data, but amplified with satellite data. You see basically the same thing. Warm water the whole way across the Pacific. The depth and the amount of warm water here in the far east equatorial Pacific is growing. That is a good sign. Plenty of warm water here spilling off the maritime continent into the West Pacific. We just need a good strong burst of the active phase of the MJO to pump more warm water. But basically, this almost looks like a Kelvin wave pushing the whole way across the Pacific and filling the upper thermocline almost completely with effectively neutral water temperatures. So kind of just as neutral as you can be, but this warm water down here suggests that maybe something better is to come. That is a bit, I'll just give it away a little. There are conflicting signs in the atmosphere and the models on what's exactly going on, but subsurface-wise, it looks like warm water is on the move, and that is a good sign. Pentad sea level anomalies, these are not temperatures, these are the height of the ocean. You have a satellite, beams radar down, it measures the height of the sphere of the ocean. Take out the waves, the wind waves, the tides. Is the sphere higher or lower than normal? Why does it matter? Well, cold water at depth, there we go, contracts. And when it does that, creates a divot on the ocean surface. Warm water at depth expands. It'll create a bump on the ocean surface. And that's what this is, a mapping of the surface height. Okay, so Chile, Peru, Ecuador, Central America, EQ, the equator, dateline right there, New Guinea there. We have effectively neutral, maybe just a little bit below neutral, but you have these above, just slightly above neutral heights here in the East Pacific. You have clearly above normal heights in the West Pacific. We had a pocket there, and we've had off and on little pockets of slightly above normal temperatures here. But all this, now notice you do have cold pockets here, here, and here, but it's really 5 degrees north and south of the equator that matter. So right on the equator, say it's pretty much neutral, but just north of that and south of that, you got some lower than normal, indicative of lower normal temperatures down in the oceans, So pretty much a neutral pattern. Upper ocean heat anomalies, okay, West Pacific here. East Pacific here. These are temperatures going back a year till July of 2024. Blues colder than normal water. That was our La Nina signature. We hit about mid-March and that just evaporated. Notice the building warm water in the West Pacific. Here is what I'm calling a Kelvin wave. I don't know that it really is. It's just more like a creeping tide east of neutral, 0 to half a degree above normal, maybe a little bit more. And it reaches the whole way now to 95 west. So almost Ecuador's like it as at 80 west. So, but notice the push to the east tapped out the warm pool in the far west. We need an active phase of the MJO to create west anomalies to take warm water over the maritime continent and start spilling it into the West Pacific to recharge this basin. But anything that gets us to neutral and not into cold is a good thing. Sea surface temperature anomalies. So our current state is, and again, it's only 5 degrees north and south of the equator, South America, Central America, Hawaii, New Guinea there. There's the equator date line right there. The yellows, you see, warmer than normal temperatures, so it's kind of neutral right there. But you see a generalized warmer than normal temperature across the entire equatorial Pacific. Now, these are corrected temperatures. They're trying to filter out the global warming signature. I think it's biased a little bit high by maybe 0.2 of a degree. That's the margin of error here, -2 to +2. Okay, so my guess is if you take that conservative view, we're still probably dead neutral the whole way across the equatorial Pacific. Let's go look at the trend for the past 7 days. You can see basically no change here in the West Pacific. We're not getting warmer. The green is neutral. That's about where we are. A little bit of pockets of warming here east of the or west of the Galapagos. One pocket of cooling, but pretty much a dead neutral trend. Sea surface temperature anomaly difference from the global mean is another way of trying to get rid of the global warming signature, but this goes too far in the other direction. It suggests, this is probably cool by, overcooled by about 0.3 of a degree, something like that. It shows a clear La Nina signature in the surface temperatures, suggesting stronger than normal easterly anomalies all in this region. Keep that in mind, though, because we're going to get into something in a little bit with all the warmer than normal temperatures over in the west. And then the 15-day sea surface temperature change says this mixture of cooling and warming in the East Pacific, but otherwise pretty much dead neutral over the rest of the Pacific. The more I look at these charts and the more I use them, the CDAS Nino 1.2 index, the more I really think this is probably closer to the truth. This is just, I think there's some correction in here, but it's not nearly as much. Anyway, this is the area right there by the Galapagos in Ecuador. It says on average temperatures are 143 thousandths of a degree above normal, which is effectively neutral. And you can see the trend actually has been down, but just working its way into normal. Then we go to the Nino 3.4 index. That's the official El Nino monitoring region out on the equator from a point south of California out to almost the dateline. Temperatures today, 77 thousandths of a degree below normal right there. Normal is considered half a degree below normal to half a degree above. So we are slowly inching our way into as neutral a neutral water temperature pattern as you can get. And I think that's what's going on with looking at all the previous sea surface temperature charts, is they're all saying we're slowly inching our way to neutral. But bear in mind what is down below the surface. We saw all that warm water, and it looks like a Kelvin wave, though I wouldn't really call it a Kelvin wave, is working its way across the equatorial Pacific, and it will eventually erupt to the surface. Keep that in mind. Again, corrected sea surface temperatures. This is for the Nino 3.4 region right here, 1/10 of a degree above normal for the week of June 25th. So neutral, and you can look back and you can see since, well, goes off the chart, but basically since February, we have been in some flavor of neutral. What does the atmosphere think is going on? We look at the Southern Oscillation Index, the difference in pressure between Darwin, Australia, basically over the maritime continent, Tahiti over the equatorial Pacific. When pressure is lower in Tahiti, the index goes negative. Hey, minus 24.56. We were negative again the day before that. 2 days does not make a trend, though. You could get just some little tropical low pressure that's hanging directly over Tahiti, or some building high pressure that's going to hang for a couple days over Darwin and skews the numbers. Looking back for the past month, we see we've been kind of bouncing around somewhere either side of zero. No trend really obvious. Let's go look at the 30-day average. Hey, look at this. We are negative, minus 0.36. Where were we a month ago? Plus 4.23. Yeah. The MJO affects both this and this, but this is saying, well, with no MJO, the ENSO signal seems to be getting washed out and it's neutral. In fact, The 90-day average really is what I use to measure whether we're La Nina or El Nino is prevalent. Today we're at 1.32, which is effectively neutral. Where were we a month ago? 4.83. So clearly there's some indications that we are dipping towards a neutral pattern. Everything saying neutral. And here's the data graphed out. 0 is right there. The solid line is the 30-day average. You see it actually dipping below 0. And the 90-day average moving from 5 down to about 1 or 1.32. It even says it right there. So we're moving in the right direction. Hopefully, we'll get some benefit from that. And finally, outgoing long-wave radiation, real-time data. The blues, wetter than normal air. The oranges and reds, drier than normal air. So this would be like your La Nina signal. Oh, date line running right up the middle. You see we had drier than normal air here all of last fall and winter. It dissipated. Our wetter than normal air, the signature is building right on the hairy edge of the door into the West Pacific. We want to see these blues starting to encroach somewhere over into here, but we're not seeing signs of it yet. I think what we really need is some MJO activity. I mean, I think we're neutral in the atmosphere. We need some active MJO activity to help build the blue pattern here if it's going to happen. Raw data from the CFS version 2 model for the Nino 3.4 region sea surface temperature anomaly forecast. I've heard from some of you. I talk to people when I'm out surfing in the water, and everyone's pretty concerned about this dip that showed up about 3 or 4 weeks ago, maybe a month ago. It was down at one point to minus 0.8 degrees. The latest version shows it may be dipping to 0.55 degrees, which isn't even La Nina. It's just cool. It's cooler than normal temperatures, and that's supposed to start falling about July 20th, I'd say, maybe July 25th. This line right here is the middle of July. One of our readers pointed it out. It isn't the beginning, it's the middle. So somewhere as we get into August, temperatures are supposed to start falling. This is the raw data. The PDF corrected, which I think is generally considered the more accurate, says temperatures only get just barely to 0.5 of a degree. I think this would almost constitute ENSO neutral if it were to happen. Now let's go look at some other data from the CFS model. Here's the sea surface temperature forecast for the Pacific Ocean. I know they're really small. I'll click some of them. Here's July. We'll just pop that open. And there's those cool pools, north and south, neutral, dead neutral across the Pacific, warmer in the West Pacific. Then as we get into, you see here, August, September, we'll go to October, shows a weak cool signal. This is at like half a degree below normal signature. And then as we get into December, well, even that kind of fades. Basically, this suggests neutral, but also notice this horseshoe pattern, just like we saw on the global average temperatures, suggesting, well, trades might still be biased a little bit stronger out of the east and some flavor of La Nina in the atmosphere, just given the distribution of water temperatures. And then here is the CFS model's prediction for rainfall. And I don't really care about July and August or even September, but then you get into October here, shows drier than normal over the entire west U.S. coast. I mean, October, that's kind of normal. You get into September, though, it's showing much drier than normal here in Northern California. I'm sorry, that was November. And December, you see a full La Nina pattern in control of the California coast. So the CFS model clearly is suggesting some flavor, though maybe we wouldn't literally classify it as a La Nina, but it's saying between water temperatures and rainfall pattern, a La Nina pattern for this fall. But is that the way it's really going to be? Again, it still feels like we're in springtime here. and that we haven't even made the transition to summer yet, which is not unusual. So that snow, that video I showed you all of up in the high elevation, I mean, pretty much every year around sometime, give or take a week or two, we go up there, we hike, and I got pictures year after year of the snowfall pattern. And there is still a fair amount of snow up in the high Sierra as compared to other years. Not markedly so, but enough to go, wow, there's a bit more snow here than what I remember from years past. And it wasn't just one place. We went multiple places, did the same sort of survey, and got the same results. That speaks to, again, that ties to the northwest wind pattern in the California coast, where it's been like nuking northwest winds, suggesting a cooler than normal pattern this spring, so the snow hasn't melted off, and sort of maybe hints at, a little bit stronger high pressure than normal, which to me hints at lingering remnants of La Nina still in the atmosphere, and we've seen that in all the charts. Okay, now the real kicker is, and the MJO, we're going to tie that in now. The MJO, very kind of not really there right now. I mean, that's not unusual during the summer either. So none of this is anything that's like lighting my hair on fire going, oh, we're into some horrible La Nina pattern come this fall. One, I don't even know that we're completely out of the springtime unpredictability barrier yet. The CFS model is the only model that's screaming gloom and doom. And even at that, the worst it's screaming is, well, maybe a bias towards weekly cool. Coming this fall. It's not even saying La Nina, it's just saying ENSO neutral bias cool. The other models, we saw the consensus model, was it 2 weeks ago, and I think I even showed it again last week, says everything, all other models are saying dead neutral. So I'm not going to go get myself too upset over one model, though I do tend to put a lot of stock in the CFS model. I think really we need to see kind of where we're at come August. Does the MJO wake up? Do water temperatures actually get cooler, which I can't see it happening because there's a whole giant mass of warm water subsurface in the ocean. I mean, something just doesn't make sense. My guess is it's the neutral pattern. The atmosphere doesn't know what it's doing. Now let's zoom out for a second. Let's talk about, we've had swell in the water. There's another swell building for California right now. There's another gale that is starting to form as we speak over the in the central South Pacific. That should produce swell for Hawaii and for California. So we have a swell pattern. Nothing huge at all, but there has been steady surf so far this summer. And it sort of seems like that pattern is going to go on. What does give me a little bit of pause is the lack of momentum in the atmosphere. The MJO is not strong. The warm water buildup pattern is not strong. The trade winds are not stronger or weaker than normal. Everything's just kind of happy in the middle, and it's going to take some energy for the atmosphere to wake up and actually do something. Will that happen before we get into the fall and winter? I don't know. I really don't. I guess we're going to have to wait and see. If you have an opinion, I'd like to hear about it. I always value what you all have to say. All right, so that's our forecast for this week, which is a whole bunch of, we got to wait and see. It's kind of neutral. I'm not sure it could go either way, but I don't think it's going back to La Nina. Whether it will move to something warmer is still up for debate. If you enjoyed the video, give us a thumbs up. If you haven't subscribed, please subscribe. Click the Stormsurf icon down in the lower right-hand corner of your screen. And if you'd like to make a small contribution to the cause, you may hit the super thanks button down below, the heart with the $sign in it. Thanks so much for your contributions and for your time this evening. I appreciate spending time with you. And with that, we are done for this week. We will do it again next week. Same time, same channel. Thanks so much for watching.